This will be a demonstration and a walkthrough of FIBERSIM's new design performing utility. There's three parts to the utility: setting up the press tools, running the simulation, and then viewing the results. Here is the setup of the press tools. It's going to be linked to the two different tool surfaces. Define your tool motion, your path, and the timing. You can preview that motion and then save the results. Then in the forming simulation object, here's where you set up your simulation using the press tools that you had configured earlier. You can set up multiple press tools and have different configurations for different simulations. The next step is to link to the blank sketch. It's a simple sketch inside the CAD system. And you need to link to a sketch curve that represents the fiber direction of the blank. You can use the same the existing curve on the blank sketch or a different sketch that has the curve on it. Next, you need to find your mesh cell size. This is going to drive the majority of the time of the simulation. In this case, we defined 15 millimeters, previewed the mesh size, and accepted those results. Material information is pre-populated with some default values for woven material. However, these can be changed depending on your own custom material properties. Once these things are all defined, you can go ahead and run your simulation. There's a status and a progress bar that is given as you run the simulation. The amount of time left tends to settle and become more of a countdown as the simulation continues to run. While it's running, you can show the latest frame of the simulation, so kind of see the status of the simulation, make sure it's running, see where the simulation's at. As you can see, the top tool starting to close, contact the blank, and ultimately close and form the blank. While that's running, you can set up multiple simulations or additional simulations to run. In this case, we're going to set up a patch blank, a smaller blank that's non-full body, and run that at the same time as the other simulations. In this case, it's going to be also a 45-degree fiber direction. Mesh size is also going to be 15 millimeters, and we're going to run this simulation at the same time as the other one. Since the blank is smaller, there's less elements, then this is going to run a little bit faster. While both simulations are running, you can view the status of those simulations side by side, kind of get the amount of time left. You can view the latest frames of each simulation and see the overall status. You can close FIBERSIM while the simulations are running, edit your parts, change your tooling, change the surfaces, all while the simulations are running. Then when you restart FIBERSIM, the simulations will keep running and eventually complete. In this case, the simulations have completed, and we're going to now go to the viewing part of the utility. The simulation creates a FSF file, which is the results file. It automatically loads that file if it's linked to if you had created this viewing object from the simulation. Then you can play back the results. In this case, you can see playing back the results at a 2x speed, 2 frame increments at a time. Playing the tool closing with the blank. You can hide the tools to see the results a little bit better. There are different displays that we have. One of those is the shear angle display that uses a customizable warning and limit value for the colors. In this case, you can see that there's some significant wrinkling, or excuse me, a significant shearing around the bosses on this part, which is not surprising. These bosses are pretty deep and have some pretty tight radii, which could cause some wrinkling and shearing for composites. So you can kind of play back, see where the shearing occurs, and you can see there are different fiber displays, shear, you can some strain, and just a simple wireframe for kind of debugging. If you really want to see like the wrinkles, the detailed wrinkles, you may have to run the simulation at a smaller mesh size to kind of get that fidelity, get those small elements to kind of see the real geometry of the wrinkles. In this case, we're loading up an FSF file that was run at 5 millimeters. The viewer can read and view a FSF file that's created by somebody else or yourself. It's just creating on FSF files created on disk. In this case, you can see at 5 millimeters, you can see the wrinkles around the bosses that are really starting to occur due to this geometry. So what we're going to do in this demo is actually show a change. In this case, we're going to change, increase the draft angles and radii on this part around those bosses. This is clearly based on the shear display and the wrinkle display. You can see the problems are really occurring around those areas. So we change that geometry right inside the CAD system. Again, since FIBERSIM and this utility is integrated inside of CAD, you can just rerun the simulation, get the new results. A common workflow could be running smaller patch blanks around the problem areas so that you can iterate faster, run the simulation faster since it's a smaller blank size, ensure that the issues are resolved around those areas. And once they are, then as you see here, you can view the results of the full body to make sure that there are no additional issues once you go to a full body blank. As you can see here, the previous wrinkles that were occurring are now almost eliminated, and you can now be confident that for this orientation and for this design, you're going to have minimal issues forming this part. This is a simple demonstration and workflow of the new design for forming utility in FIBERSIM 17.